Hello there, students. So we are going to start the energy unit. We're going to move on from forces. And I thought we'd start with a little bit of a sort of an activity, a little demo to play around with. We're going to use one of these online simulations to start to learn the concepts of
conservation of energy.
So I'm going to take you through how to set up the simulation at home. Okay, so you want to go to PHET, PHET. Here it is. We are going to use the skate park simulation. So you can type it in there, energy skate park. So energy skate park. I think there are a few different ways you can get this set up on your computer. So you can download it. And I'm going to show you how I'm going to take you through that. So if I download it, it downloads. It's not a very big file. I'm going to try to open it. I think it's going to, it's going to tell me that it cannot be opened because it's from an unidentified developer, which is something that Mac does for security. So I'm going to go to my system preferences, security, and allow it. I'm not sure how this works on Windows. I'm not sure if it's a problem on Windows. I guess I need to use my password. So we're going to open that. And here it is. Okay, so this is the Energy Skate Park simulation. I'm going to give you some tips and tricks on how to use this, how to get everything going. Before I do, let me just go back. Let's say you want to do this in the browser. I think you would go to HTML5. And if you just click play here, it's going to boot up right into your browser. And we're going to use intro. So you can do it right in the browser as well. And you can use the mouse to drag the person around. And it should have all the same functionality that we have in the downloaded version. And then a third way is I think you can actually use your phone. They've got an app. It's not free. It costs $1.29. So you don't have to spend the money, but it is a really good app. I downloaded it and I played around with it, and it's pretty easy to use, and it's a good physics app for learning these concepts. Okay, so it doesn't really matter which one I use. I'm going to use the downloaded one. So you can see we have this guy skateboarding on this sort of parabola shape. Now, let's see. I'm going to pause the skater. You can change all kinds of stuff about this. So you can change the shape of the track by dragging this around. You can add more tracks by dragging one from up here and make a more complex shape. Oops. You can go into space. You can go onto the moon, on Jupiter, and you'll notice that the gravity value here is changing. If I go to Earth, we know our familiar 9.81. Space is 0. Moon is a low value of G. Jupiter is a high value of G. And you can set the value of G whatever you want. Couple other useful things you can do. I'm going to reset, going to go back to the regular one. Now, okay, so this guy's moving. We can actually look at how much energy he has over time. So watch this. Take a look at this graph. You can see 4 different energies. I'm actually going to... We don't really care about thermal energy. We're not going to deal with it very much for the next little while. So you can get rid of thermal energy. Or maybe you can't. Maybe you have to have it there. Anyway, it's 0, so it doesn't really matter. So you can see how we have these 2 different kinds of energy, and we haven't actually learned what these are, but that's okay. It's just forgetting, this is kinetic energy and this is potential energy. And you can see that over time, kinetic energy is going down to zero and then coming back up to a certain number, which seems to be its maximum. And then potential energy is kind of doing the opposite. Although potential energy never comes all the way down to 0, it looks like it's got a certain minimum that it never goes below. And then the total energy, you can see what's happening with that. Okay, so that's a little graph you can look at. You can also look at a graph of energy versus position, which goes back and forth because the guy keeps coming back to the same position. So you can see at each position on the parabola shape, how much energy of each type does he have, kinetic and potential energy. We can also look at a bar graph, which is just going up and down as he's skating. You can look at a pie chart, which will actually show it right here on the right beside the guy, moving along with him. And let's get that. There's a place where we can actually get rid of thermal. And I don't know, what else am I going to show you? I guess I can show you, well, obviously you want to use the dog because that's way more fun. And if you want to, you can make the dog fly. Let's make the dog fly off into space. And go. Oh, nothing's happening. Well, that's because we're in space, so there's no gravity, so there's nothing causing the dog to move at all. So it says here, press the arrow keys to apply thrust. So let's, there he goes. He's having a good time. Okay. Dog is now flying through space. So, oh yeah, the other thing is if you go up to here to tracks, they have some built-in tracks that are kind of fun. So you can try like the loop. So let's, oh, I mean, I don't care about this dude. I just want the dog. All right. Let's see what happens with this dog when he goes around the loop-de-loop. Oh, yeah. Oh, he must love that. He's having a good time. And you can slow it down, too. If you really want to kind of examine what's going on with the energy here, this is a good way of seeing how the pie graph is changing by slowing it down. Yeah, so that's about it. I haven't shown you absolutely everything. Some of it is left up to you to discover, and so you're going to want to play around with this and just see what are the different options and build yourself some tracks. So, rather than using the built-in ones, you can I don't know if you can actually delete this one, but you can add on to it anyway, and you can modify it. That's not going to work. Wonder what happens here. And he falls to the ground. So that's about it. Play around with this, and we're going to be doing a lab based on this simulation. And so you're going to want to be really familiar with this in order to do the lab effectively.